we want to take some time and do a battery diagnostic and electrical distribution problem with the same level of detail we've been doing other tests. This is kind of the pattern we're going to follow for other components and systems as we go through this remainder of the program. How much information can we extract from each test? What can we identify as a normal operation, and what clues can we have to future things? And we're taking something as simple as a battery. First of all, we have to understand the details of operation of the battery in order to properly diagnose it. So we're going to review battery distribution a little bit. But in the electromotive force, or the voltage sources, on a vehicle, we typically have two of them, the battery and the charging system. Now, the charging system is fairly large and complicated, and that's a class unto itself, and we really think we should spend time on that. So we're going to spend most of our time talking about the battery and clues about problems with the charging centers indicated by the batteries. Let's start off with our battery. It's an assembly of cells connected in series to increase the voltage that's available. Now, in a cell, the chemical energy is converted into electrical energy for storage and release. What that means is we're storing ions. We're having ions going through an electrolyte and depositing on the cells. We have an excess of negative ions on the negative cell and an excess of positive ions on the positive cell. Positive ions need an electron to return the atom back to normal. Negative ions need to release one electron. Fairly straightforward. Now, most of the storage batteries we use in vehicles uses sulfuric acid to surround plates. Sometimes we wrap them tightly and try to increase the area, because the amount of current we can put out is determined by the amount of electrolyte, the availability of ions, and the surface area of the plates. So we put a lot of plates in parallel, connect them together, and then hook that cell to the next cell in series. Now let's talk about what we're talking about. Here's what it looks like on a 9-volt battery. We didn't buy one 9-volt battery. We actually bought 6 1.5-volt batteries connected in series. If one of these cells go bad, it's going to destroy the whole battery. We're going to talk about that when we do battery testing and look for that capability. One of my favorite questions to ask in class is, when is a 12-volt battery 12 volts? And the answer is when it's 75% discharged. What does this have to do with anything? Well, first of all, if we have a car that drives into a shop and we see only 12 volts at the battery, we know right away there's something wrong. But let's go in and explore this in more detail. Something starts happening to batteries when they get below 12.4. Sulfation, an insulation that increases internal resistance, starts to increase anytime the specific gravity gets below 1225. That's 1.225 for those of you who want to be specific. This sulfation causes problems. It increases internal resistance and is one of the causes of battery failure. Sulfation hardens the battery plates and reduces its ability to supply voltage and to accept a current. It's a theory of reciprocity. If it fights a charge, it will not store enough electricity to provide a discharge capability. Keep in mind, it's the same thing. If I can't charge, I can't supply. The chemical activity slows when the battery material is cold. This is why we have cold cranking amp ratings. An adjustment must be made for battery temperature during testing. Our specifications have to change. We can't test a battery at 0 degrees the same way we would at 70 and use the same numbers, because the chemical activity had slowed down. We've got to compensate for that. Cold weather starting is the reason batteries are rated for cold cranking amps. 550 cold cranking amps. That means it puts out 550 amps during a discharge at 0 degrees Fahrenheit and stays above 7.2 volts for 1 minute. That's its ability to start in cold weather. That's what the newest rating is that most people use. It's not the only rating on a battery. Let's talk about adjusting for this temperature. If we look at the temperature of the electrolyte at 70 degrees, if we apply 1/2 the cold cranking amp load for 15 seconds, we accept 9.6 as a reasonable number. But if we drop only 10 degrees, we have to drop that voltage 1/10 of a volt. If we increase up to 80, it's 9.7. If we're at 100 degrees, which is fairly normal, if you look at the number of times you've tested a battery that's 100, it should be 9.9. The point we're making, understand what it is you're testing. Look at the details, because you might miss a battery that is marginal at 100 degrees Fahrenheit, which is not exceptionally warm. And if you look for a 9.6 volt load, you're already 0.3 of a volt wrong. It is not as good as you think it is. We're going to talk about some alternate ways of testing. But the typical way most people test is you hook up a carbon pile with an ammeter and a voltmeter and do your testing. Now here's some things happens. If we run a test and we fail our 9.6 and the open circuit voltage is below 12.4 volts, we have a battery that's discharged. We need to do some special testing. Our question is, with this 3-minute test, is this discharged battery going to accept a charge? Well, we start off by charging it at 40 amps for 3 minutes. Now you will find batteries that are sulfated that will not accept a 40 amp charge. That's a key right off the bat. After 3 minutes, the charging voltage must not be higher than 15.5 volts. At 40 amps, it should take longer than 3 minutes to charge this battery back up. That's what this test result says. If I cannot accept a charge, I cannot deliver a charge. We're going one step beyond just load testing and saying, oh, it's load tested, the battery's kind of weak, I wonder if it will supply discharge current when I try to start the car. If I can't charge it, I also can't load it. That's the point. If the voltage is higher than 15.5 volts, replace the battery, because it's very unlikely it's going to come back. If it's below 15.5 volts, slowly recharge the battery and repeat the load test, compensating for temperature. Remember, after you charged it, it's probably going to easily be 100 degrees, and you're going to need 9.9 volts for your 1/2 CCA 15-second load test. See the detail we're going to? See what we're doing here? We're going beyond just your routine testing and trying to do more. And we say recharge slowly. A fast charger is a really great thing, except don't try to overdo it. This is an example of what happens when you overdo it and somehow you get a spark. This happens far too often. Now, there is a specific time it takes to recharge a battery. We use 80 degrees Fahrenheit as a typical number. If the battery is colder than 80, you need to allow more time. Let me say that one more time. If the battery is less than 80 degrees Fahrenheit, it's going to take more time. One of the biggest mistakes people made about discharged batteries is they charge it for 15 to 20 minutes and say, well, that should get you down the road. But look at what it really takes. If I'm at 12.4, it should take 30 minutes for the battery to fully charge. Look, if we're at 11.8, it's an hour and 55 minutes to recharge this battery. Don't expect it to accept a charge quickly if you're down in 12 volts or lower. Give it time to accept it. Let it make sure that it is going to fully recover. If you had a battery that wouldn't start a car because they left the lights on, odds are you're in this 12 volt range, somewhere in that area, and a 15 or 20 minute charge is not enough to turn it loose. You have to pay attention to this. Now, there's a new method of testing batteries invented a few years ago called conductance measurement. What's strong about the conductance measurement is that it does not rely as heavily on the state of charge. It does a better job of analyzing the battery. Now, what we're going to do is we're going to take a low frequency, low voltage AC signal and impress it across a special set of terminals and measure the current through the battery. What this is checking, it's checking the chemical activity of the ion movement in the electrolyte and the surface area of the plates. It's somewhat independent of the state of charge. The reason you find interstate testing with these small little meters that don't have a big load bank is they're using this type of technology, and it's more accurate than the load bank testing, mainly because most people don't completely do the load bank test like we've been discussing, and recharging and so forth. The conductance is calculated using a reverse version of Ohm's law. Rather than look at ohms, we're looking at the opposite of ohms, the ability to conduct. It's something you might want to look at if you haven't tried it before. It'll give you a cold cranking amp reading that's fairly accurate. But the temperature It has the greatest effect on battery charge and discharge behavior because the battery changes in internal resistance with temperature. If the battery's cold, internal resistance goes up. Now we said battery performance decreases, chemical activity slows down. We've got a lot of words we use. What we're really saying is internal resistance goes up with a cold battery. That's why we have bigger voltage drops. That's why we drop only 10 degrees from 70 and we accept 9.5 volts as open circuit voltage with 1/2 cc applied for 15 seconds because we have higher internal resistance. Understand, when you're looking at voltage drop, you're really testing internal resistance and seeing how much voltage is dropped in the battery at a given load. Extremely cold or hot temperatures both affect the battery performance and life. Cold conditions cause reduced performance. High temperature increases the self-discharge rate and increases the chemical activity that can damage the battery during high charging rates at high temperature. Keep all that in mind. At 80 degrees, we say the battery is 100% efficiency as a reference point. At 0, we're down to 50% efficient. Remember, that's why we use 0 degrees for our cold cranking amp test. It's telling us we can still put out 550 cold cranking amps at 0 degrees is a very important rating. A completely discharged battery may not initially accept a charge. It may be a very low current, which may not even show up on your charger ammeter, because it takes a while. As we discharge a battery, we're changing sulfuric acid into water. 1275, 1265 specific gravity indicates a certain amount of sulfuric acid. Specific gravity of water is 1. As we discharge the battery, it goes from 1265 heading toward a specific gravity of 1. At 1, we have nothing but water. So when you get ready to charge, understand your process is to change water back into sulfuric acid. That's the charging process. Now, take the time on electrical testing, because electrical problems can be simple or complicated. Because the charging system is so critical for vehicle operations, take a few minutes to analyze the primary electrical system when you work on a vehicle. AC ripple voltage can cause unusual performance problems. We've seen very, very strange ones. And of course, low charging voltage can cause very erratic operation on many of the systems. So we're going to use a voltmeter. Set up our VOM. First thing we're going to do is select the voltage ring. Now we're going to tell you to do something specific. We're going to say select the manual voltage range. You say, why do you want the manual voltage range? Because during the testing, we don't want this changing ranges. We want it to give us one set of readings we can stay with. We do not want auto ranging in this particular case. We're going to remove the surface charge in the battery. And the way we do that is we apply a heavy load for 15 seconds. A load like 1/2 cca for 15 seconds. Or crank the engine for 15 seconds as an example. Then we connect our voltmeter across the battery terminals. And we're going to see what the voltage is. Now here's a chart. If we go back to 12.66 volts, we've got 100% charge. It'll take it a few seconds to get back there. Take the time after you take your load off to watch how quickly it goes from removing the load back up to full voltage. If it takes over a minute for it to get back to full voltage, you have low activity in your electrolyte. It's getting old and worn and not working very well. If we're down below 1245, below 1240, we've got to go back and do our 3-minute test. This all tells us something about the vehicle. If we have a vehicle roll in the shop and we first start looking at it, if it's not above 12.66 volts after someone just drove it in, we haven't been charging the battery that well. There's something wrong with the charging system. Take the time to look at this. And when you take the look at this voltage, we'll look at 12.76 volts in this particular case. Also take the time to look at the temperature. At 83 degrees, we've already had to change our load setting from accepting 9.6 to now we have to pass a 9.7 volt load. And if it was 60 degrees, we'd be looking at 9.5 volts. If it were 100 degrees, we'd be looking at 9.9 volts. You have to look at the whole picture. Why is that little tester better? Because it pays attention to all this information right here. The reading on the left with the red writing, there is a surface charge and this battery was recently charged. On the right, the surface charge has been removed. Maybe we've hooked up some test equipment. We've been playing with our scan tool a couple of minutes. It would be perfectly normal to see 12.6. But initially, you're going to see close to 13 volts, like we see on the left. If we don't, the vehicle that just pulled in hasn't been charged. So 1266, that's kind of what we expect for a 100% state of charge. If the open circuit voltage is 155 volts or higher, the battery's fully charged, the car's working fine, and all you got to do to run this test is crank it for 15 seconds. If it's less than 1255, we got to start worrying about it. Has this vehicle been driven enough for the battery to be charged after a deep discharge? Go back to the chart and see how long it should charge at 40 amps before you release it back to the customer. Is a battery drain reducing voltage when the ignition's off? Is that the reason this might be lower charge than normal? You see where we're going? We're taking a simple voltmeter, cranking the vehicle 15 seconds, and finding out what the real state of charge is on the vehicle before we start jumping to conclusions or missing problems that could cause reliability problems. Is there excessive starter draw? A good battery cannot turn over a starter that's worn and drawing excessive current. Battery terminals corroded. We have seen so many battery terminals corroded in the last few years, it's scary. Is a charging system problem? Why is this car not being charged? What's going on? Is the battery itself defective? There's questions to be answered just because we saw one slightly lower than normal voltmeter reading. Why aren't we at full charge? Why has this car not been fully charged? That's what we've taken the time to do. Take the time to look at it. Specific gravity. It's a great measurement if it's possible. Now, don't remove seal vents or destroy the battery or mess it up just to do the specific gravity. That's not what we recommend. But the advantage of measuring specific gravity over open circuit voltage is you can find weak cells because we're going to look at the acidity or specific gravity, ever how you want to say it, for each of the 6 cells in a 12-volt battery. Remember, one cell in a battery starts going bad, we're going to have a problem in the future. How bad? A weak cell will lead to lower capacity. If it's well off the norm, you've got a problem. Then the temperature of the electrolyte helps improve accuracy because most of the better systems of measuring specific gravity also show you the temperature. Let's talk about the results from our specific gravity test. If we read 1265, for you mathematicians, that's 1.265 specific gravity, which is equal to 100%. That yields about 2.1 volts per cell. Put that in perspective, that's 12.6 for 6 cells. But if we come up and look with our hydrometer, we've got 3 of them. Good at the top right, better at the bottom right, best is the optical in the middle. It's got the best compensation and gives us the most accurate reading. We look up and we find one of our cells in a fully charged battery is down around 1190, 1200 specific gravity. That cell is never going to charge up with the other cells in series with it. All the current in that cell to bring the specific gravity back up has to pass through the fully charged cells. If you have a weak cell that's not fully charged, as indicated by specific gravity, no amount of charging is going to bring it back because in order to be charged, the current has to flow in series, like we showed that little 9-volt battery. If one of those little 9-volt batteries is discharged and you try to charge it back up, no way is it going to be possible because it has to go through the other batteries to get there. All of these cells are hooked in series. So when I have one of these that's well out of line in state of charge, that battery is going to be bad. If I'm around 1200, I cannot trust the 1200 cell when I've got others at 1265. The battery is going to fail soon. We're going one step beyond regular testing. Mind you, we don't recommend this for all batteries because sealed batteries, this is difficult and we can't do it. We have to do it by open circuit voltage, cold cranking amps testing, and our other voltmeter system. Is the battery good? Is it worth the time it takes to make sure we have a good battery? Absolutely. And staying with B+ to ensure that the charging system is normal on the other half of the electrical system is working normal is definitely worthwhile. Check the starter draw and cranking speed. Even a good battery can't start a bad starter in cold weather, we've talked about before. Check the grounds. Quickly check the batteries, the engine, and the body grounds. And we'll do it during our test procedure as well. Grounds are just as important as power. Don't misunderstand that. They can be tested quickly enough, which gets all of them out of the way, and it's done and over with, and we can go on. Right here, we got a good ground. Remember, the ground is from the engine ground back to battery negative. We've got 3 millivolts here, practically nothing. And we've got the key on, of course, so we can draw some current flow. Now, in the upper left, this is an actual problem we found. Well, there's the broken harness. This vehicle was in for a flash reprogramming, and it wouldn't flash reprogram. They couldn't figure out why. That's the computer ground. There's also ways of measuring parasitic draw. You got special tools, can measure it for you. You got adapters to make open circuit, or you can use your low amps probe. How long does it take computers to go to sleep? These days, this number is different than it used to be. No vehicle is going to have 0 milliamps after you turn the ignition off. We're going to see a couple hundred milliamps, and some vehicles take 15 to 20 minutes. We've heard even higher numbers before they go to sleep and start turning computers off. And on modern vehicles, we have to have computers that stay awake all the time. If you have a keyless entry system, it's a computer that's going to unlock the door when you push the button. It has to be awake. You need to get a good spec. We expect to see it drop down to 50, 75 milliamps in most cases. There are a few vehicles with lots of computers, really elaborate. 100 milliamps is not abnormal. The clue is anything that's drawing high current with the engine off and the computer's asleep is going to have very large capacity batteries. You're going to start seeing 900,000 CCA batteries. That's telling you it's going to have a big amp draw with the key off. There's a number of vehicles that the manufacturer warns you, if you leave them 3 weeks, they're going to run the battery down all by themselves. Be careful with parasitic draw. Those of us using old techniques are already outdated because of all the computers. Powers and grounds are good. Spending a few minutes here, checking parasitic draw and all the electrical system is really important. Remember, the electrical system can cause problems that strand the motors and cause for very unreliable operation.